what it means to build a new home in an existing structure. We're in South Boston today. We're at this iconic standalone building. It's going to be a single family home for our client. I want to talk about what it means to have good bones, how we're maximizing square footage in a city dwelling, and lastly, how we're connecting new construction with old construction. So we're gonna go inside, we're gonna meet for our senior site super, Chris Sullivan. We are in a standalone building, which is unique to South Boston. A lot of buildings are connected, a lot of them are row homes, and when they purchased the property, we looked at it, and one of the things that we all said was, it has good bones. Chris, what does that mean in terms of when we're looking at a structure?
It's a good starting point. Gave us a great starting point for the house. As we started demoing the house did end up being a complete gut.
And being a masonry building, we're actually stripping it down, all of the wood framing out of it. One of the things that we talked about was, could we save some of the floor framing? And we considered that originally, but ultimately we made the decision not to.
We did consider that in the beginning, but what the structural engineer wanted us to do, and over 100 years, this house is over 100 years old, there were countless remodels on the house, which ended up compromising a lot of the floors. So it didn't really make sense to really save any of the floors. It made more sense to kind of strip out each floor, build our way back up, and frame new floors. That way we could start out level and plumb inside the structure.
The way that you had went about that was kind of interesting, because we originally had left the second floor in place. You guys actually built a structure to support the second floor to rebuild the first floor. If you were to strip all the floors out of a building like this, you actually run into an issue where the walls want to push out and disconnect from one another.
And the roof wants to flatten out. So we had to hold, the only part of this house that really stayed as part of the original structure was, of course, the brick walls on the exterior, and the roof ended up staying. So had to hold up that roof as we ripped out each floor and rebuilt each floor.
You have the brick walls, and if you have the floor framing that essentially holds those brick walls from pushing out, because the weight of the roof sitting on top. So if you remove all the flooring and anything that's holding those walls from pushing out, that roof wants to flatten out and essentially cave into the structure.
The way they used to frame it was they would frame their joists into the walls. And
it was kind of little brick pockets.
Little brick pockets. So it was kind of a loose fitting. The engineer wanted a positive connection for each floor just to tie the building kind of all back together.
So we ran into many issues, like especially around the roof. We found that the slate roof was painted. There was rot in there. There was bad flashing details. But the brick, you know, it's a pretty thick, I think it's like a 15-inch wall.
Yeah, it varies between 15 and 16 inches thick.
I guess the question oftentimes comes up, why not just knock it down and rebuild? The truth of the matter is, from a permitting perspective, it can be very difficult to build this particular building here. Beyond the permitting side, it's just wasteful. There's a lot of good here.
Good material. I mean, you got brick walls all the way around. To rebuild this structure would be a fortune. And then we created, basically, I call it a mechanical wall to run all our outlets.
So this furring here was essentially
that's original, exactly.
100 years ago, they would anchor that back to the brick, they would lath it, and then they would flatten the wall with plaster.
Correct.
And now we've essentially left that strapping, mainly because there's no benefit of ripping it off. It's just labor. No. And you're framing a 2x4 wall in front of it. When we think about maximizing square footage, you're typically paying a premium per square foot for a home in the city. This wall has to be off of the brick, but it needs to be as tight as possible to allow for not only our insulation code requirements, but also for our mechanical code requirements.
Bringing modern amenities into a house like this can be difficult, and building a wall like this makes it a little bit easier. You know, and that's, you know, as much as we hate to lose square footage by going all around the wall, it's a needed thing.
Why do that rather than just push the exterior walls as tight to the brick as possible?
Because it'll show up at the end. Everything shows up on the end in trim. So we have to make sure that everything is square to some point inside. So when you start putting kitchen cabinets on the exterior walls, if things are out of square, it's going to show that. So we have to build a square structure inside an existing structure.
Sure, you could get an additional inch or 2 inches by following the brick wall, but now your rooms feel crooked. One of the things that we see a lot in the city is digging down.
Yes.
Utilizing the basement.
Yeah.
So the basement here was actually pretty usable. It was a comfortable height, but it still felt as though it was a basement. So we brought out a geotech, and we also brought out the structural engineer to understand, can we in fact excavate the basement and get additional height in the basement, which we were able to do. So can we go down there and walk through how we
we'll go through the whole process.
So originally we were about, I think, 8'6" to the framing, which, correct me if I'm wrong, this is our sewer line going out.
That was actually underground.
And that was underground. We'll come back to this new concrete in just a moment, but this is, you actually can see all the new floor framing. You actually rebuilt a lot of this masonry?
Yeah, so when we demoed this floor, this was really compromised all along here, so we had to bring a mason in first to redo the masonry. And then we drilled holes and epoxied and bolted everything in. And that won't be that's not structural at this point.
This is not structural?
No, what it is, it's just causing a positive connection between the two walls to hold the two walls together. We did this on this floor and we did this on the second floor.
How do we deal with structural?
Structure is gonna be, we're gonna use our shelving wall as the structure. That'll actually end up being the structural part of.
I mean, it's being held up and there's people walking on it now. So it's really, it works, but from a structural calc perspective, as an engineer looks
as an engineer, yes.
Live load, kitchen load.
Correct.
A couple thousand pounds of nice, beautiful marble, countertops. They want that as a positive, direct force down.
Yeah, on this wall and the far wall.
And that wall. In the middle, you have, it looks like maybe a 16-inch or so LVL, and they're 4 and 4, and this is running down essentially a column line. You pocketed the ends. I noticed that the guys actually wrapped the end of the LVL with tape. Correct. So essentially you don't have to deal with a pressure treated or your direct contact with masonry on both ends. These go down to footings, and then your flooring is hung off joist hangers and then back over to the masonry wall.
Correct.
Now I think we're just about under 10 feet down here, which is a huge improvement.
Yeah.
And changes the space from a basement to essentially living space. Because ultimately this ends up being a bathroom with a sauna, a game room, and essentially a theater.
Movie room.
Movie room. Which is great space, especially again, back for the city. So let's talk about the existing foundation first. This is essentially a field stone and granite foundation?
Yes. The company that came in to do the underpinning and all the repairs to the existing foundation, they ended up skimming all the walls, filling any voids, any holes in the walls, and then they sprayed this with a waterproofing product that they use. That's
like a crystalline.
It's a crystallization of, they spray it on, they do 2 or 3 coats, and what ends up happening is as water actually comes through the foundation, it actually activates the waterproofing, and the waterproofing will actually travel further out as it gets wet. So it crystallizes inside. You can actually see some of the crystallization on the wall. And it's actually working. You can actually see over time, it's getting drier. The walls are getting drier and drier.
I was gonna say, I was here last week when they had placed a slab, I think 3 days before, and it was wet. It was actually substantially warmer down here because the concrete was curing. Like a new construction foundation, you'd pour a concrete wall, you'd actually spray a liquid waterproofing on the outside of that wall, and before you backfill. These old foundations, they just didn't have any waterproofing at all. They just allowed the water to seep through and essentially down into what would be the dirt floor.
Correct.
So Drycrete Waterproofing was the contractor that came in. They did a
fantastic
job with the underpinning, but also the waterproofing. And like Chris said, as that water's coming through from the outside, it crystallizes and essentially keeps the water from making its way through the wall. With this drainage mat, if water were to make its way down, water actually can make its way behind this drainage mat, and then there's a perimeter drainage.
We have a French drain system.
French drain system all the way around in a stone, and then it goes to a sump pit over there.
Correct.
So there's a redundancy with, especially an old basement, you really want that redundancy to make sure that if and when water does make its way into the basement, you're getting rid of it and you're protecting your finished space here. The underpinning, you're taking your bottom of your foundation and you're extending that foundation down. If we were able to hold the house up from a cloud, we could dig out all the way around the whole building and then pour new concrete underneath it, and then it would just be lower. But if we were to do that, you'd essentially compromise the structure and it would fall.
Correct.
So you do it in sections. Do you remember?
Yeah, you can kind of see it. You can kind of see the sections that they did. The first process they did is they dug the basement down, all around the middle, and they left the perimeter dirt piled up against to hold back that foundation. And then the geoengineer actually mapped out how he wanted them to dig out each section.
Did they do 1, 2s, and 3s, or was it 1s and 2s?
They did it by color.
Color. How many colors?
4 colors.
They came and they essentially marked, I'm gonna make up red, blue, green, yellow.
Yeah.
And then they would come in and they would do all the reds?
2 sections a day they ended up doing. So there was like 2 reds on a wall on each wall. So they did 2 reds here, 2 reds on that wall, 2 reds on that wall, and 2 reds on that wall.
Got it.
They would pour it. They actually did each color or section every day. So every day they were doing a new.
So they weren't just doing excavating, they were excavating and pouring.
In one day.
In one day. So that way it's not sitting there unsupported. You're basically
Correct.
like, you're finishing that scope by the end of the day.
Correct.
So, and if you can kind of visualize this, you're essentially extending a section of the foundation, over there, and as Chris is saying, 2 sections on each wall a day. Your unsupported area is very small. It's 3 to 4 feet or something like that.
Correct.
And allowing you to drop that foundation down, and then over time, I think it was over the course of 2 weeks-ish?
Yeah, 2-3 weeks.
2-3 weeks. And once that's done, now you have your lowered foundation wall all the way around. This shelf detail right now is about 8 inches out of the wall. To what Chris said, this is a structural wall now, which will support all of our framing. But this wall extends underneath all the way to the outside face of our home. If we were to consider that this wall is as thick as the brick wall above, which is about 15 inches, another 15 inches in that direction is where this concrete goes to make sure that if you were to excavate the outside of the building, essentially you'd see concrete continue the face of that foundation all the way down, another 2 feet below where we're standing today.
Essentially, we dug down 4 feet to gain 2 feet.
That 4 feet is essentially getting your footing below.
Your footing, stone, insulation,
right?
Our new.
Yeah, so we have a concrete slab here, which will be fully finished with carpet or tile or something like that in the finish. Below that, you have your vapor barrier, which is the stego, and then underneath that you have your insulation, and then you have stone.
Correct.
And in that stone is where your drainage layer lives.
Correct. Correct.
You're essentially building a brand new home in an existing building. Let's go upstairs and look at the mansard framing. So on the second floor, Chris, this is where you were talking about a lot going on here. You can see a lot of the brick here. Granted, this isn't structural,
no,
but you can see how that brick just deteriorates over time. The mortar can get soft and turn really back to sand. You're actually seeing a lot of the roof framing, and this would never actually work in today's standards. This is a 2x6 framing.
No.
It looks like it's 16 inches on center, but that would not pass structural today. When the engineer's on site, he's looking at the existing structure. It works, but we want to build a new layout in here. We have this massive skylight that we're putting in. How are we essentially detailing this to make sure that roof framing is supported appropriately?
So we made accommodations in the floor framing down below. In our new walls, we put double joists on the walls that essentially are carrying now the existing mansard plate.
So similar to the first floor, you rebuilt this whole second floor, and this is where you're anchoring the top of your brick wall.
Yeah, we actually made a form inside the wall and poured concrete.
And that sits on top of your masonry wall?
That sits on top of our masonry wall.
So this is a concrete curb, which you would typically not see on the second floor.
No, we put ice and water behind it because we don't want concrete pouring up against wood. We ended up forming it and rebarring it into the existing brick wall. Because what ended up happening was this floor actually sat on top of the brick walls. It was kind of notched up and sat on top of there. But there was no positive connection at this point. They just kind of sat on, just sat on top.
So that concrete curb becomes what you're anchoring your floor framing to.
What we ended up doing with the concrete curb is we actually used J-bolts that you see in foundations.
But in the horizontal.
In the horizontal. So we ended up setting all those J-bolts in and tying in and using the J-bolts just sideways. It's
one of the biggest questions that we get, do I really need to do a full gut? We actually did the math on this one where we were going to keep a lot of the framing. From a dollar perspective, there was no savings either way. it actually, you know, we could argue that it's probably less expensive to reframe everything than to try to fix and sister joist and leave it and accept the fact that it's old. But then you don't end up getting the new product. You get floors that squeak, floors that aren't level, and then you're pairing it with all of the structural concerns that you kind of band-aid.
That really kind of drove us taking the floors out, was the engineer aspect of it. We probably wouldn't been able to do this kind of attachment with existing structure. It would have been 10 times harder trying to get this detail done. The engineer was involved during this whole process, so it's not like we made all these decisions. These decisions were made by an engineer saying, I want it done this way, A, B, and C.
Sure, you could piecemeal it and put it together, but ultimately, you know, like you said, it's going to be very difficult to get to the result that we're looking for, as well as the engineer, when you're trying to build new within the old.
And then in the end, it makes really good sense to reframe the floor. Just, we have to bring, like I said, modern amenities. We have to bring plumbing back into here. So at this point, we're able to lay out joists. We're able to lay out walls to accommodate plumbing, to accommodate lighting. We're able to, you know, lay out joists to lighting. So where if we had the existing structure, we probably, if we fixed the existing structure, we probably end up taking out a lot of the existing structure for plumbing and reframe. So it just made sense at that point, just to...
Pre-construction and planning, right? Laying framing out for plumbing, laying framing out for electrical. You know, we have the opportunity to plan for that and work through that in pre-construction, rather than getting into it and trying to modify an existing structure. We can build all of that in preparation for those modern amenities.